think about it. You practically end up writing business logic directly without thinking about other things. And you don't need to break your business logic in a bunch of pieces, like event handlers, callbacks. You don't need to use database. You need to use a queue. You just write your business logic. For example, for money transfer, withdraw, deposit. Okay, deposit failed, do compensation. But this is business logic, 100%. And you don't need to think about crashes, you don't need to think about state. So you end up writing 5 times less code, and your code is much more fault tolerant and durable. So it's a huge increase in developer productivity.
Sounds awesome.
Yeah, and actually, you're not the first one. Tell me, too good to be true is the most common answer first time people hear about that. Because yes, it sounds too good to be true, but reality is, if you look at list our users and customers, and what companies are using that for mission critical processes, you realize that this is actually a real thing.
Good morning, good afternoon, good evening, wherever you are. This is Griswold of FINOS. Hope you're doing well. Today on the podcast, I have Max Fateev, who is the co-founder and CTO of Temporal. Max, say hello.
Hello, thanks for having me.
It's very nice to have you here. Temporal is a new member of FINOS, and we always like to get to know our members and what you're interested in within the foundation, what really drives you, how to get you involved. But this time I have the pleasure of actually talking to a co-founder, and I think that you are going to be able to bring a different perspective than some of the other interviews that I've had. So I'm really excited to talk to you today. But as I told you on this podcast, we really try to focus on the person. And so can we go back in time a little bit? Let's say you're not the co-founder and you're not the CTO, nor the CEO, we'll get into that too, of Temporal, but let's go back in time. I was looking at your resume, and you have a couple of places that you worked at, and you've had some interesting positions, but talk to me how you got started. Is this a developer journey? Is this a technologist journey? Is this something always interested in open source? Tell me, let's go back in time 20 years.
20 years ago, I was working at Amazon. I joined Amazon first time in 2002. And Amazon back then I was an engineer. All my career was an engineer. And didn't manage a single person until we started the company. And actually co-founder of Temporal as well. So we were both 100% engineers. And I joined SSD to Amazon in 2002. And Amazon was going through the big transition from a monolith to service-oriented architecture, which is now we call it microservices, whatever.
Right.
And the reason had to do that was just the sheer size of that binary. The whole Amazon website was a single binary. It wasn't actually an Apache module. And it was pretty cool because it could actually troubleshoot and put breakpoints into the Amazon website back then. The problem was that it took 45 minutes just to re-link that binary. So imagine any non-trivial change and you practically wait 45 more minutes just to see what's happened. Imagine this pain. So Amazon had to break pieces. And then I transitioned to the team, which was responsible for the frameworks and also all asynchronous communication of Amazon. So practically pops up. And we wrote a few versions of that. At some point, I was tech lead for the storage solution for messaging. And it was a base of Amazon messaging platform. So I was practically tech lead for the whole pops up architecture of Amazon for quite a few years. And it was well before Kafka was even conceived. And now I think this solution is used by Simple Queue service as a backend, Amazon Simple Queue service. So one thing I realized, and my team realized, that queues are awesome as a runtime component, but they're actually not the right technology to do practically do the communication between services. It's a tool level technology. And we realized that we need an orchestrator. We need orchestration solution, which would actually bring some order into this mess of WebSap. And we worked on multiple versions of an orchestrator, and it culminated in the release of the Simple Workflow Service. It's AWS SWF, Simple Workflow Service. I was tech lead for that. And the ideas of the Simple Workflow Service brought quite a few new ideas. And unfortunately, we didn't nail the developer experience, and that's why the service is not very well known.
Right.
But then co-founder of Temporal, Summer, who worked with me on the Simple Workflow Service, went to Microsoft. And at Microsoft, he tried to build a similar service, but Microsoft had 3 or 4 similar offerings already, so he couldn't make it a top-level Azure service. But he released the open source framework called Durable Task Framework. And the Durable Task Framework became popular, tops-down adoption, got quite a few, like adoption between Azure developers within Microsoft. And later, Azure Functions team took dependency on it. Now Microsoft has Azure Functions, Azure Durable Functions, and this is based on that idea. And then me and Samar met at Uber in 2015, by coincidence, by the way. And we were hired to build the PubSub system because we knew how to build was, and to replace Kafka. And we built an open source product called Jeremy, and partially successful. Over 60 teams at Uber were using it at some point in production. But later, Kafka improved a lot, and Uber kind of defunded the project. But out of the project, we did another project called Cadence. And that project became based on the ideas of the simple workflow and durable functions. And then this project became successful. Within 3 years, it went to 100 use cases within Uber. And quite few companies started to adopt it outside, and we started the company called Temporal. And we forked the project now. The open source project is also called Temporal.
And so were you building it as an open source project within Uber at the time, Cadence?
Yes. The interesting thing is that because we built Jeremy, and we are allowed to open source that. Nice thing about Uber back then, Uber was very open to open sourcing infrastructure projects.
Mm-hmm.
And the problem is that we initially built it as closed source, and then we're like, okay, let's open source it.
Right.
And then it took us half a year just to clean it up, to remove the dependencies.
Yes.
And it was pretty significant effort. So when we started Cadence, we said, no, this is not going to work like that. So we practically started to develop from the beginning in the open. And it forced us to do all the dependency management correctly and make sure that the open source project is self-contained. And if you go to our GitHub repo, you will practically see the check-ins from the beginning of time there. That's why this project was being open from the beginning, and we used the very permissive MIT license, and we still use a permissive MIT license for everything. So Temporal is fully open source without any license games. And there are quite a few companies using that in production at large scale without any commercial. We don't have enterprise version, so that is another thing. It's only open source MIT license, or we can talk about this later, a hosted offering.
Oh yeah, no, I definitely want to get into that. But now I want to go back to something that you said at the beginning. And so for Temporal, not only you're the co-founder and the CTO, but you used to be the CEO. But I want to get into what you said as far as you start a company and that's the first time you've managed anybody. Tell me about that experience. How, just on a human level, what were the things that you had to learn? Because the reason I asked this question is because I think that there are a lot of engineers and a lot of developers that they are incredible at what they do. And what is the first thing that a company does when you have somebody that's so awesome at their developer or engineering job? What does the company do? They promote them to manager of people. And then all of a sudden their entire world has to change. It's a whole new experience. And there are many specialists that they really want to do that thing that they do so well. And sometimes managing people isn't their thing. So I ask you, as a current and former engineer who then had to manage people that are now reliant on you in your company, what's that experience like?
I think there is big difference between a just manager and being a founder.
Yeah, true.
So especially if you're, and also being CEO in general, because as they say, CEO in most cases can outsource, find people who will do things for you. So you can create a role to feed yourself, right? So if you're a CEO who likes management, who likes HR stuff, who likes that, you can absolutely spend time there. If you're a CEO who likes technology, you technically can find people who will do management for you. So I think it's not as clear cut, you become a manager.
Sure.
If you're just talking about management, it is absolutely different skill set, right? Yes, an engineer can become an awesome manager. It might become an awful manager, but it's a really different skill set. You practically need to, it's a career change, right? So you are becoming something else. Yes, your technical skills might remain. Obviously, they will become rusty with time, but it's a different skill set. You need to approach that, okay, I'm changing my career path. Now I'm trying to become somebody else. I need to learn new skills, and I need to forget quite a few skills, at least put on the shelf and to use them. But certainly I've seen quite a few successes and I've seen quite a few failures. when people did realize that this is not just, okay, we'll do something else on the side. It's a complete reversal of what we're doing. And yeah, but one thing I would say, don't fear to be a founder. Don't fear to create your company, because you will get all the help. One thing, what I loved about the whole startup ecosystem in the US, at least, is that we built something people wanted. And all the other things, we got huge help from our investors. We've got obviously money, which doesn't hurt. But I think just we've got help with hiring, we've got help with organizing the company. So it wasn't as scary as we thought.
That's good.
But this time, what happened is that I was able to manage the company, was able to find people to help me. But obviously, it was first time I was doing that. And second is that I just found that I like technology much more than just building a business.
Mm-hmm.
I'm much more involved every time there is a technical problem, there is a customer conversation, there is a new feature to discuss. We're also thinking about how to do comp plans for the salespeople. There are people who enjoy these things, so I prefer do what I like. And also, as I had an awesome co-founder who could actually take that role, it was a relatively easy decision, because certainly when you need to bring an external CEO, you don't know what will happen. It's a certainly much larger risk. But when we are fully aligned as co-founders, it was a much easier decision for me to go back to, now I don't have a single report. I do purely technical stuff.
That's good. And I will say that as relaying this story to somebody recently, my dad taught me how to do oil changes on my car when I was young. And to the point to where I was doing oil changes on his car. And I probably did that into my 40s or so. And then I was visiting my dad at his house one day, and he was talking about that he'd just gone somewhere to have his car serviced and got an oil change. I'm like, wait a minute. You've been telling me for years that I should be doing my old oil changes and I shouldn't be paying somebody. You need to do it yourself. And he looked at me and he goes, yeah, at 60 something years old, I finally figured out that there are people that do that for a living. You pay them, they're really good at it, and they do it a lot better and faster than you do. Then he can focus on the things that he really wanted to, right? And personally, I'm honestly with you. I have a small staff, and as much as I really enjoy mentoring them and working through problems with them, I enjoy doing podcasts. I enjoy doing some of the technical things too, building a website, which I used to do years ago. I don't get the chance to do that anymore. So I understand that need, I guess is what I'm saying.
But yeah, as one of my mentors told me, that I'm lucky, that I can pick and choose what I do and should do it. Not everyone has like that luxury, unfortunately.
This is true. So let's talk about, you co-found this company, and because you've seen an obvious need that's come out of 15 years, basically, of working on very similar problems. You were explaining to me before we were talking about durable execution and how that affects developer experience. So can you define that? And, let's talk about durable execution. Or did I get
So durable execution is practically a new abstraction, which didn't exist before. And there are different ways to introduce it. But for you, whoever wrote code, let me give you an introduction which kind of makes sense for an engineer.
Okay.
And the idea is very simple, is that imagine a runtime which preserves the full state of code execution all the time, durably. So imagine if you have a function, this function calls three APIs, like A, B, and C. For example, I don't know, withdraw money, charge money, and notify customer that transaction happened. And then imagine you are blocked on withdraw money or deposit money.
Mm-hmm.
And then process which hosts this function crashes. So the runtime can move that function to another machine, and it will be in exactly the same state. It will be still blocked on deposit. It still will have all the variables and all the state preserved there. And it will continue, and then the deposit returns maybe 3 hours later, and it will continue executing. So logically, think about process that cannot crash because machine crashed, data center crashed, the network went out. This process will recover automatically and continue executing as nothing happened. That is the basic idea. But it's a super powerful idea. Why? Because it eliminates need to deal with so many edge cases and problems. For example, Usually, most of the code is a bunch of callbacks, right? Oh, I've got a request. I will go to database, load that request, modify something, save to database. Why? Because my process can crash anytime.
Mhm.
If you use durable execution, you can just store value in a variable, and as durable execution is durable, all variables are durable. So you can practically store something in a local variable. You need to talk to database anymore. So
Right.
all your state is durable, and you don't need to do ORM, practically no queries, nothing like that. Then any API call can take any amount of time. So if you're calling a function, as I say, deposit, if deposit takes 3 days because there is a manual approval there, you still blocked in the same API function because process which called it cannot crash.
Right.
And that also means that this function can run as long as you want. So it can run for a year, for example. Imagine subscription implemented as a loop. You can say for loop 12 times, charge customers, send them a notification, and run it for a year. And you can run it for every customer separately. That is the idea of durable execution. And it also replaces transactions in distributed systems because, think about it, it guarantees that things will happen, which is like main thing about transactions, right? Because practically you can guarantee that certain operations, certain calls will guaranteed to be happen in presence of any failures. And you as an engineer, we need to think about that because it's taken care of by the underlying system.
So this is all about resiliency. But so how does it for the developer, for the engineer? Like, I know that I've got a safety net, but how does that affect my developer experience?
So think about it. You practically end up writing business logic directly without thinking about other things. And you don't need to break your business logic in a bunch of pieces, like event handlers, callbacks. You don't need to use database. You need to use a queue. You just write your business logic. For example, the example I gave you for send email, like a charge send email, right? And sleep 30 days in a blocking manner, right? Because they can practically use it. This is pure business logic.
Right.
And try to implement it in any other way. And then say, okay, scale it to 100 million customers or like 500 million customers. So that is, I think, the interesting part is that you practically end up writing business logic. The same thing for money transfer. Withdraw, deposit, okay, deposit failed, do compensation, but this is business logic, 100%. And you don't need to think about crashes, then you think about state. So you end up writing 5 times less code, and your code is much more fault tolerant and durable. So it's a huge increase in developer productivity.
Sounds awesome.
Yeah, and actually, you're not the first one. Tell me, too good to be true is the most common answer first time people hear about that. Because yes, it sounds too good to be true, but reality is, if you look at list our users and customers, and what companies are using that for mission critical processes, you realize that it's actually a real thing.
Specifically then for financial services, like, can you kind of state the obvious benefits then? Especially because I know that I believe that you deal with payments and online orders and things like that. But on the financial services sense, can you say the obvious benefits that somebody?
Yeah, I think the most obvious benefit is that if you think about financial services, they are practically all about resiliency and guarantees.
Right.
And almost any process there. Okay, you are signing up a customer. It's a process which can take a long time, requires manual approvals, can spawn multiple days, or like you do probably dozens and maybe hundreds of API calls, contains complex business logic for orchestrating what happens if certain conditions. Some of that is dynamic. And this is a very common use case, for example, for this technology. And payments. Payments can be fast, practically instant payments when you need to respond within milliseconds. But why would you use this technology? Because you need to guarantee compensations if something goes wrong, right? You need to return error to the user within 100 milliseconds, but then you need to say, okay, if I already made quite a few API calls, now I need to run compensations in background. So practically what people will call as a saga pattern. And the temporal is durable execution is the way you implement saga pattern and it's very common. There are quite a few banks which standardized practically temporal co-payments because for this use case. And then almost anything. For example, ANZ Bank in Australia, they implemented fully out electronic mortgage process. And they tried to do it a traditional way. And I think after 1 year, they got stuck. And then they got practically a new group of 2 or 3 people which were learning the technology from scratch. And I think they got POC out in 6 weeks.
Wow.
And now they're all their like a mortgage application going for this technology. And they have dozens and dozens of other use cases as well. You can find it online, but they're pretty vocal about this. They talk on our meetups and they present at our conference. Almost anything this bank does requires resiliency. So it's applicable in hundreds and hundreds of places. I know that we're talking about data pipelines, analytics, machine learning, AI. For example, the whole agentic stuff right now is very heavily uses this technology. Because what is agentic flow? It's a workflow, right? Practically, you need to execute sequence of steps, very dynamic because AI can tell you what to do, but you need to guarantee that these steps happen. And you can talk to multiple AI endpoints and so on. And you need to link all of that together resiliently. And quite a few AI companies are using Temporal for that.
Gotcha. Can we now go to Temporal's open source? And you started building, it's an MIT license, right? Why would you build in open source and have that as your core for your business?
So we built it initially at Uber.
Right.
And I think why Uber did it, I cannot say for the company, but my personal opinion is that building infrastructure level project like database, queue, or something like rebuild, and not open sourcing that is actually doesn't make sense.
Mm-hmm.
Why? Because this technology will stagnate. I've been to Amazon. You cannot imagine number of cool technologies Amazon had at the beginning of 2000s. And Amazon was 10 years ahead of almost everyone. And then it culminated in Amazon Web Services at some point.
Right.
But we didn't open source a lot of those technologies. And this time they died. Right? They practically became irrelevant because what happens is that you develop this technology, but as you don't get much adoption outside of the company, initial team usually leaves, people move around, right? Company has other priorities. I've seen quite a few infrastructure projects which died because they were built within a company and never made public. So if you're a company, and yes, if you're like huge vendor, like I'm like one of those hyperscalers, maybe it's a different story now. But if you're a company, normal company, even very large company, and you're building an infrastructure component, you absolutely have to open source it if you wanted that component to survive over years and become a real thing. So I think it was pretty reasonable solution for Uber to open source that, because now this technology lives and it lives outside of Uber as well, and it certainly will have longevity. And Uber, which uses that in thousands of places, certainly will benefit long term from that technology being open source.
So I'm sure the question that you probably get, and again, I ask obvious questions because honestly, I don't know if I told you, but the listeners of this podcast, they're developers in banks and engineers there. They're also business people inside of banks as well, developing business cases. So, and some of our board members are managing directors that, they have buying power as well. But the question will always come up, and especially in the past couple of years, is open source secure? And we talked about the resiliency that's needed, obviously, within banks, but there's the security side as well. How do you address that when you're talking to a managing director and saying you can trust open source, whether it's this or Temporal built on open source or any other open source project?
I think there are different issues there. My understanding, most of the issues happen because of supply chain, right? Just people using wrong dependencies. I think with Temporal, there are a couple of things there. One is the Temporal architecturally broken into the backend cluster and then the K libraries. Similar, for example, like if you think about Kafka. Kafka has backend cluster and has publisher and subscriber library, right? And that application runs outside of the cluster, right? The same way, Temporal has a backend cluster, and then has SDKs, which you link it to your application and deploy as part of your application. And this SDK needs connection to the backend cluster. It's in the gRPC connection. By design, SDKs can encrypt everything before sending to the backend cluster. So what it means that even if the backend cluster is fully compromised or even hostile, it still cannot see the information. It's by design because you own the encryption. You can plug in your own keys. That's why even obviously I can say, oh, cluster is secure. We have SOC 2 Type 2 compliance. We do scans. We do all sorts of things. But it doesn't matter because even if the cluster is hostile, the data is encrypted by you. So if you trust your encryption, then the backend cluster cannot do much with it. That's why, for example, our monetization model of our company is not by creating a kind of limited open source and then have an enterprise version, right? Like open core. No, we are not doing that. We have fully featured open source MIT licensed version. And then we have cloud hosted version, which hosts only the backend cluster, and you still host your applications. And as you control your applications and you encrypt everything, and application need only connect to the backend cluster, never back, we can pass security reviews of biggest banks in the world without problem, because just we are secure by design, not by because we promised you. Besides, we have all the compliances as well, right? So type 2, we have, I don't want to give your own list, but we have them. But it's not about that. It's about having the right architecture.
And yeah, then maybe when I was saying open core, I was definitely going the wrong direction based on what you do. That's and on the back to the founder side of things. I think within open source you always hear about open core, or you had the Red Hat model of just doing, which originally how they started, just doing the words are escaping me. Yeah, like. It's the consulting side first, and then building the operating system, all the above. But this is a different model, I think, than I've seen. It's very interesting, and I think that some founders should actually take note, not in this space, but as far as working through an open source project and how to help a customer. So again, I'm just saying that's interesting to me as somebody who's been in startups before. I don't know that I've really thought about this type of model.
But if you think about it, practically every open source company moves that direction right now. Confluent has Confluent Cloud, right? Mongo has Atlas. And these are, as I know, the fastest growing segments there. And they believe that the long term, this is better for their customers. And we believe so as well. Because we know that if you start using our cloud right away, that you just get to production much, much faster, and you have much better experience. So I think it's the right model. But at the same time, obviously, any technology is lock-in. That's why we want to provide fully featured open source version. Because if we are not fair to our customers, you can just always take our open source and run it yourself, or somebody else will start running it for them. It guarantees that we are doing a great job serving them.
That's a good backup too, or a proof point. So that's good. That's a good point. There are two things I want to ask you about before we go. One is about your conference in March in London that I think you just did one here in the States, but that's called Replay. And I believe your CFP, your call for papers is open right now for that.
Yeah, so we have an annual conference called Replay. We just had one in Seattle area. It was very well attended, had 750, I think, people. And if you go to our website, replay.temporal.io, you will see quite a few very interesting videos these are very good companies presenting there. So you know about all of them. Cool. And I absolutely recommend watching those videos. But if you have, especially if you're in Europe, who can travel to Europe, please join us. It will be March 3rd to 5th in London. And yes, if you are a Temporal user already, please submit a paper, talk. We'd love to hear more customer stories or more technical details about what you're doing.
We'll make sure that we have that we'll have that as a link on our website, not just on the show notes for this episode. Thank you. And then the last thing I want to ask you is let's forward facing within financial services, open source and financial services. Let's maybe just leave it there. This, again, the answer may be a little obvious, but I want to get your take on it. What do you think is within open source and financial services? What in the next 5 years? Obviously, we're dealing with AI, but in the next 5 years, what are the things, or one or two things that you think like we really need to pay attention to as a community? Within the FINOS community, but outside as well as a larger open source community. I'm just going to stop talking. Leave it there.
I think, as far as I know, financial services mostly consume open source, right? They don't produce that much open source. And they are one of the largest consumers of open source, which is awesome. And I think more and more, like obviously new frameworks will appear, but it looks like, as I said, monetization model moves more and more to hosted services. And one thing we certainly witnessed that a lot of companies and a lot of banks are reorganizing. I was certainly super impressed and actually surprised by the quality of talent at the banks. Because my impression was I will meet people who've been around for 50 years. They just thinking like COBOL and whatever. And now almost every leader at banks I talk to, and we talk practically to every major bank in the US and abroad, being in the industry, they mostly came from the digital native companies. They have experience at Amazon, they have experience at Google, they have experience at all these companies. They understand space very well. They understand what it means to build distributed systems, how to build real resilient systems. And that's why we have very good traction with them, because they immediately understand the value of what we are providing. And so far, I was impressed, and I'm pretty sure that this type of leadership will bring a lot of change and positive change to the banks. And I think I see a lot of modernization going on. Some of that is cloud migration. Some of that just breaking these monoliths. Some of that is just making systems much more kind of API driven. And this is where we come in, because we are replacing a lot of event driven architectures, because people try to migrate to the cloud. They start building services. They start using event driven. They end up in the mess because there are no APIs if you use event driven, right? And then when they come in and explain that there is a better way, that you can do request reply, which takes 5 days, for example, and still have nice APIs, they get hooked on that. And then I realized that, yes, you can actually rethink about how you even design those systems. But I think a lot of modernization going on, and in a good way, because banks want to move faster. One thing I found is that big banks, because there is a lot of fintechs in young companies which move extremely fast, they force big banks to move faster. They practically realize that there is competition out there, and if they just stay at the same kind of level and don't adopt new technologies, they will be left behind. And I don't want to do that. So there is actually very healthy competition going on right now. And I really enjoyed being part of that.
Very good. Well, Max, thank you so much for joining me today. I think I say this with just about every guest, but I learned, this is the reason. This is my individual contributor nature to do something like this and talk one-on-one with somebody. But the truth is I learned so much just talking to somebody like you. It ends up making my job easier. And actually that last piece that you said about how banks are really starting to adjust, it's why FINOS was formed in the first place. And as far as I'm concerned, that basically puts exactly what we're trying to do out there from somebody else who understands. So I appreciate you understanding the plight of what we're trying to do, because it sounds like that's what you're trying to do as well. So we appreciate that. So I think we're going to stop there. And to the audience, I'm going to say good day, good night, wherever you are. And Max, thank you so much.
Thanks a lot for having me.